And then, okay, yesterday we talked about square root functions, and this is our parent function, right? And we plug in perfect squares so that we can get whole numbers outside. And then we have vertex form. Now, I showed you what vertex form is, but I didn't actually show you how to graph with it. I kind of told you how you could do it, but there's a beautiful thing that you can do so that you don't have to make a table each time. And some of you were struggling on how to make a table. Now, this was a note. Like, this was a problem in your note. It was also a problem on your homework. Crazy that you could have just looked back at your notes to figure that out. I don't know what I was thinking. So, what we're going to do is you can actually plot your vertex and then use your perfect squares and your counting numbers, just like we did with parabolas in vertex form, to graph it. So in this one, our vertex, there's nothing under here. And remember, your vertex is HK, right? And it's the opposite of whatever this is, and then K. So what you can do from your starting point, which here it's 0, 0. Does everybody understand why it's 0, 0 right here? Because there's nothing under here, there's nothing outside, so it's 0, 0. What you can do is you can go right 1, up 1, right 4, up 2, right 9, up 3, and you don't have to do a table. So you can use those every time. Every single time. So I want to write that down on here. So let's make sure we have this out so we can add that to our notes. So you go right your perfect squares and then up your counting numbers. Right your perfect squares, up your counting numbers. You go right the perfect squares, and then you go up the counting numbers. And you can do that once you get your vertex for every single one of them, including ones that have the number out front. It's crazy.
Up the perfect squares, right the counting numbers.
Write the counting numbers, up the perfect squares. So remember, with parabolas, it was up the perfect squares, write the counting numbers, correct? So it's opposite of parabolas, what we're doing today. Now, let's look and make sure it's right. This one, our vertex, do we have anything under the radical? No, so it's 0, and then this number 1. So our starting point is 0, 1. Is that where we started? Okay. And then we need to go, remember, we're going right the perfect squares, and then we're going up the counting numbers. So we would go right 1, up 1. Is that what we did there? Okay. Then we go right 1, 2, 3, 4, up 2. Is that what we did there? And then we go right 1, 2, 3, 4, 5, 6, 7, 8, 9, up 3. Is that what we did there? So it still works regardless of if you move your vertex. Does anybody have any questions? Okay, for this guy, what's our vertex here? What's our starting point? 0, negative 2. All right, is that where we started? And then we would go right 1, up 1. Is that what we did? Right 4, up 2. Is that what we did? And then right 9, up 3. Is that what we did? Oh, and Emily, we didn't do one with a number outside. I'm sorry. I thought we did. So then, let's do this. Now, you should be able to apply what we did in class yesterday to your homework. It's crazy. But with the numbers out front, you have to multiply after you plug in your numbers under the T table. Now, how many of you got confused on what you actually plug into the T table? That's okay. Did you try to plug in 0, 1, and 4 and get negative numbers and you're like, but I can't take the... Okay. So remember what we said when we got to this guy right here was that you shift what you plug in so that you get 0, 1, and 4 under the radical. So if we're shifting what we plug in right here, what would we plug in to get 0? Positive 6. So to get 0 under there, we'd plug in positive 6. What would we plug in to get 1? Positive 7. And what would we plug in to get 4? You guys know that 10 minus 6 is 4?
Yes.
2 people know it? Okay. All right.
Wait, how did you get those numbers?
Because I'm trying to get 0, 1, and 4 under the radical. So I'm manipulating what I plug in so that I don't get negative numbers. Now, another way you can do this is you can find your vertex. So what is our vertex here?
6 and 5.
Take the opposite of this, so it's positive 6, and the same as this, so it's negative 5, yeah. So you had the positive 6 right, you just needed the negative on your 5. Good job. Okay, so let's go write 6 down 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Why are these so tiny? Did Miss Compton come get a index card off my desk? Okay, good. All right, now this number, normally we would go right 1, up 1, but we have to multiply our up distance by this number right here. So we would go right 1 and then up 1 times 5 is 5. So we would go right 1, up 1, 2, 3, 4, 5. Then after we go right 1, what do we go right next? What's our next perfect square?
4.
4. So we go right 4. 1, 2, 3, 4. Up 2 times 5 is 10. So we go up 10. 1, 2, 3, 4, 5, 6. And then you connect. So when there's a number out front, you just multiply your counting numbers by that number. Down here? No, don't, because it stops right there. Now, that's a great, thank you for pointing that out. The reason is, because if we plug in if we plug in positive 5, which is our number to the left, correct? 5 minus 6 is negative 1. Can we take the square root of negative 1? No, so that stops there. It has to end there. It can keep going up, but it cannot go any further down. Now your domain is x when x is greater than or equal to 6. Because that's our starting point on the x-axis is 6. And then your range is y when y is greater than or equal to negative 5. Because that's where our y's start. Does that help a little bit? You don't have to. That's what I'm about to show you how to do next without the chart, using vertex form. Now, I want to do 2 and 3 together using vertex form, and then I want you guys to check your 4, 5, and 6 without me, okay? Or finish 4, 5, and 6, or, whatever. So number 2, let's start with our vertex. What's our vertex of number 2? Negative 2, negative 6. Good. Because it's the opposite of whatever's in here and this number. Can everybody, blink so that you don't have this glazed zombie look in your eyes and then pretend to pay attention? At least zone out looking at the board. Can we try that? Thanks. Alright, so let's go left 2 and then down 1, 2, 3, 4, 5, 6. Now remember, we're going to go right our perfect squares, and then we're going to go up our counting numbers times 2. The reason it's times 2 is because of that number right there. So I'm going to go right 1 and then up how many? 2. Because 2 times 1 is?
2.
That's why we go up 2. And then I'm going to go right 4. And then I'm going to go up. 2 times 2 is? 4. 1, 2, 3, 4.
This is vertex form, right?
Yes, this is vertex form.
Is it like on all of them?
Yeah.
Oh.
That's why I'm showing you this way so you don't have to plug in a table. It's awesome. Alright, then you go right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And up how many? Where'd you get the 6 from? Awesome. That's it.
Go right now, right?
Yeah, that's our last one. So we went right 1, up 2, right 4, up 4, right 9, up 6.
Oh, you know right.
Okay, now what is our domain? Remember, domain is your smallest x value. So what is our smallest x value? Negative 2. And what's our range? What's our smallest y value? -6. And it's always going to be your vertex or your starting point. So you can just take these numbers, wherever your vertex is, and plug it into your domain and range. That's all you do. Does anybody have any questions before we do number 3? Are you confused on anything on what we did on 1 and 2?
So when we go right, it's like either 1, 4, 9.
Yes. Yes. The perfect squares. Yes, ma'am? What? I don't know what word you're saying.
Or it's moving back and forth in the air.
Oh, okay. It's not going to hurt you, baby. Okay. Calm down. Stop and focus on the math, you weirdo. All right. Now, who besides Miriam, Nathan, and Allah can tell me what the vertex is of number 3? 2, -1. Awesome. So you go right 2, down 1. Now remember, we go right our perfect squares. We're going to go right 1, 4, and 9 if we can. And then we're going to go up 5 times 1, 2, 3. And if you need to write that every time, do it. There's no judgment. All God's children. So we're going to go right 1 and then up how many? 1, 2, 3, 4. Oh, I can't see sitting down at that angle. 5. Okay, and then I'm going to go right 4, up how many? And I can't go up anymore. So there we go. Can anybody besides those 3 tell me what my domain is? Awesome. Can anybody tell me what my range is? -1. Yes, perfect. All right, now do 4, 5, and 6 without me. And if we get done, we won't even start a new lesson today. We'll just do this, and I'll let you have... All right. Sorry, guys. Okay, so your vertex is -4, 0, and then you don't have a number out front. So you go right 1, 4, 9, and you go up 1, 2, 3. So you go right 1, up 1, right 1, 2, 3, 4, up 2, right 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3. And then you connect your dots, and boom.
I did that. I'm smart. I did it.
Stop that. You're not 5. So then it's x when x is greater than or equal to -4. And your range is y when y is greater than or equal to 0. You did? I'm so proud of you
I told you I'm real good at this.
for today.
Yeah, you literally know how to do it. I'm real good. I got it now. I just have to have the teacher then. Okay, so we'll do this every time there's no number out front.
Because I don't ever teach you.
No, I need to take a teacher home for that.
That's how we record the videos.
That doesn't help.
How do you know? Have you watched them?
It's about
No.
Okay then, you don't know if it helps. And y'all, like 75% of your college classes are now online with a video and a teacher talking to you.
I'm going to college for that. Nope. No thank you. I'm gonna.
I may not go to college.
Alright, 0, 1 is your vertex for number 5. So you should go up 1. And then it's right 1, 4, 9. Up 2 times 1, 2. I'm talking, hush. So then you go right 1, up 2, right 1, 2, 3, 4, up 1, 2, 3, 4, right 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3, 4, 5, 6. Because we have that 2 right there.
Okay, I did it wrong.
Now, the reason that it's positive is 0, positive 1 is because this 1 is not under the radical. Do y'all see how the radical ends? That means it does not cover that 1. So your domain is x when x is greater than or equal to 0. And your range is y when y is greater than or equal to 1. Who got that one completely right? Yay! Good job.
I thought it'd be 1.
For X?
4. Yeah.
Oh, okay. Well, do you see why it's not? Okay, baby, you see how the radical ends?
Yeah.
That means that 1 is on the outside. That means it's the K. Do you remember how yesterday in our notes I made a hook at the end of mine? If you need to make a hook at the end of yours so you see it ends, make a hook at the end of it. Alright, now this -5, don't put it in the tray, put it on my desk. This -5 is under the radical, but that +2 is on the outside. Okay, so make a hook right there. And then that's +5, 2. Thank you.
Chris, what did you say? That's fine, push it.
So then you go right 1, 2, 3, 4, 5, up 2. And then we don't have a number out front, so it's right 1, 4, 9, up 1, 2, 3. So right 1, up 1, right 1, 2, 3, 4, up 2. We can't go any further, so boom. Did anybody get that one right? Hey, that's a much higher number than the others. Great
I
job.
got that right.
Yes, super
We're
proud.
not this is the main range, so I can see.
Okay, it's X when X is greater than or equal to your X value of your vertex. Y when Y is greater than or equal to the Y value of your vertex.
All right.
Every time. Alright, now 8 you can do on your own. 7 and 9 you can do on your own. Use Desmos and see what that number out front does to it. It's magic. And then, once you finish with this, turn it into the tray. Make sure your name, number, date, class period's on it. And work on any makeup work that you owe me. Does everybody understand?
Yes.
Okay. Yes, ma'am. Yes, ma'am. I'm going to move it down. Alright, Chabakas, calm down.
That's very good. I have to go get glasses this week.
Pardon?
I have to go get glasses.